Questions 11 through 20 on the 2016 grade 10 AMC 10A. What is the area of the shaded region of the given 8 by 5 rectangle? Well, this side is 5 and this side is 8. And what they've done is they've got this shaded region. So let's see what we can do to try to figure out the area. Chop it in half. So drawing that line down the middle. And let's see. I'll probably call these areas A, B, C, and D. So let's take this one step at a time. So the total area of the shaded region will be, of course, A plus B plus C plus D. A, it's a triangle, 1/2 base times height. The base is 1 and the height is from here to here. And that height is this divided by 2 because of the symmetry of the diagram. So it'll be 5 over 2. And then I've got to take B into consideration. Same kind of thing, 1/2 base, which is 1. But that height is going to be from here to here. And again, because of the symmetry, it'll be 8 divided by 2, which is 4. And then the C and D pretty much are the same thing. 1/2 base times height for C, where this is the base and this is the height, which is 4. And then D, 1/2 base times height, where this is the base and this is the height, which is 5 over 2. And I think that's it. So let's add up all these. So we have 5 over 4 plus 2 plus 2 plus 5 over 4. So this will be 5 over 2 plus 4, and that is 2.5 plus 4, so 6.5. And of the answer choices, that would be D, 6.5. 3 distinct integers are selected at random between 1 and 2016 inclusive. Which of the following is a correct statement about the probability P that the product of the 3 integers is odd? Let's let those 3 integers be A, B, and C, and they are distinct, and they're chosen between 1 and 2016, and we want their product to be odd. Well, the only way for that to happen is if all 3 are odd. Odd, odd, and odd. If you have any other combination, the product will end up being even, like even, 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 or 1 even, 2 even. And try it out, you'll see that the only way to get a product to be odd for 3 numbers is if all 3 are odd. Okay, so let's figure out the probability, P. The first one, we want it to be odd, and it's between 1 and 2016. So half of those are odd, right? Half are even, half are odd. So what's half of 2016? 1008. So the probability of getting an odd number, if you select one number at random from 1 in 2016, is 1008 over 2016. It's basically a half. Okay, now I've got to talk about B. The key word in this question, in my humble opinion, is distinct. I think that's what would make people get the wrong answer if they didn't concentrate on the fact that the numbers have to be distinct. So if I choose a number for A, I cannot choose that number again. So now I've only got 2015 numbers to choose from because one's already been chosen for A. Of the 2015 numbers, how many of those numbers are odd? Well, one odd number has already been taken out. So of the remaining, of the 1008 odd numbers, one was already taken. So there's remaining 1007 odd numbers. Okay, and then now by the same sort of principle we talk about C, and again A and B are already gone, so now we're down to 2014 numbers. We already chose 2 odd numbers of the 1008 odd numbers, so there's only 1006 odd numbers left, and that's the probability. This 1008 over 2016 is exactly a half, but this is 1007 over 2015 is slightly less than a half. So that means I've got to make this a less than symbol. Less than. And this is also slightly less than a half. So less than. So basically less than 1/8. So P has got to be less than 1/8. And of the answer choices, That's A for number 12. 5 friends sat in a movie theater in a row containing 5 seats numbered 1 to 5 from left to right. The directions left and right are from the point of view of the people as they sit in the seats. During the movie, Ada went to the lobby to get some popcorn. When she returned, she found that B had moved 2 seats to the right, CC had moved 1 seat to the left, and D and ED had switched seats, leaving an end seat for Ada. In which seat had Ada been sitting before she got up? All right, so this is one of those questions you just got to play around with this. All right, well, I'll just call them A, B, C, D, and E, the 5 friends. Initially, I have no idea what order they're in, but I do know that after the popcorn, I guess, when Ada gets up and gets the popcorn, the seats are as follows. Wherever B was, now it's B plus 2. So, if you're going like left to right, it'll be B plus 2, and that's basically directly from the question stem that B had moved 2 places to the right. Wherever C was, now it'll be C minus 1. A is going to be in the end, so either here or here. That's what end means. So A is in the end, so the position number 1 or 5. And then D and E just flip. So wherever D was, E is going to be there, and wherever E was, D was going to be there. Okay, let's start off and see what we get. A is going to end up in an end seat, so I'll use 1 as a possible. B is now 2 places to the right, so let's just say B was initially here, so 2 places to the right means B is going to end up here. So B is going to be there, right? B plus 2, 1 space, 2 spaces to the right. C, let's say C was here, and then after the popcorn it goes minus 1, so 1 to the left, so C ends up here. And then D and E, if they were like this before, they're going to switch spots and become E and D like this. And this all fits. So if it fits, it works. So this is where it is after the popcorn. Where were they before the popcorn? Well, before the popcorn, B was here, C was here, D was here, and E was here. So A must have been there. And that is position 2. So number 13, the answer is B. How many ways are there to write 2016 as the sum of 2's and 3's, ignoring order? All right, so 2 times something plus 3 times something is got to equal 2016. So we just make a little table, and off we go. And hopefully we definitely are not going to fill out the entire table. We're just going to get some sort of a pattern. Okay, well, I guess the lowest value for x is 0. And when x is 0, y will be 672. And you can easily... All right, let's keep going. When x is 1, this will be about 671.3, I believe. 33. When x is 2, this will be 670.66. That's no good. We've got to have integer values for x and y, because those represent... they represent a certain amount of 2's and a certain amount of 3's, whole numbers. When x is 3, then you get an integer. So basically what it means is that x has to be a multiple of 3. So for 6, you'll get 668, and so on down. And at the very end, when y is 0, this becomes 1008. And you can easily calculate this by plugging in values into that equation. So it looks like x is a multiple of 3 all the way up until 1008. So to figure out how many of these we have, ... 1008 divided by 3, and then don't forget to add that guy, so plus 1. So this looks like it will be 336 plus 1, which is 337. So 14, the answer is C. Seven cookies of radius 1 inch are cut from a circle of cookie dough as shown. Neighboring cookies are tangent, and all except the center cookie are tangent to the edge of the dough. The leftover scrap is reshaped to form another cookie of the same thickness. What is the radius in inches of the scrap cookie? Well, the scrap cookie is basically the full, I guess, diagram minus the 7 little guys. So the full is pi big R squared minus 7 of those smaller ones, so pi small r squared. And then do they give us anything? Well, they give us the small r, that's 1. But the big R, they didn't give us, but I can figure that out. Draw a line that runs all the way through like this, and then you can clearly see that the radius of the big circle would be, if this is, say, small r, small r, small r, you can clearly see that the radius of the big circle is 3 of those small r's. And since each of those is equal to 1, the radius of the big circle will be 3. So it's pi 3 squared. So this is 9 pi minus 7 pi, and that is 2 pi. So 2 pi is basically the area of the scrap. Now once that is, combined and then rolled out into the shape of a circle, it will be some pi r squared. We'll call it radius of the scrap, rs. Okay, so now we just have to solve this. The pi's cancel. I forgot to put that squared there. So the pi's cancel, and we get radius of scrap squared is 2. Take the square root, and you get radius of the scrap is root 2. And there you go. Number 15, the answer is A. A triangle with vertices 0, 2, negative 3, and 2, negative 3, 0, is reflected about the x-axis. Then the image is rotated counterclockwise about the origin by 90 degrees. Which of the following transformations will result in the reflection going back to the original, basically? Okay, so what I'm going to do is try to make it easier to understand, I hope. Maybe not, maybe more complicated, but we'll see. You be the judge. So instead of dealing with a triangle and a bunch of vertices and a shape and all that, I'm just going to use one point. That's it. And I'll call that one point X, Y, or whatever you want to call it. Let's call it AB. And this is the 1 point. And that 1 point, obviously, is going to be, in this case, in the first quadrant. It just makes it a little bit easier to explain. So let's do exactly what the question is saying. First, reflect it in the x-axis. So this is the x-axis right here. When I reflect it in the x-axis, where the x-axis sort of behaves as a mirror, then that point will come down to here. It will be A and negative B. The A coordinate stays the same. The B coordinate just flips from positive to negative. Now we are going to do the next, which is rotating counterclockwise about the origin by 90 degrees. Okay, so to better understand this, let's just draw a line from the origin to that point. Then we're going to basically rotate 90 degrees till we get to right there. That's 90 degrees, right, approximately? And the length has to stay the same, and I'm pretty sure I made the length the same. So this is 90 degrees, so that's a right angle. And then now I've got some coordinate here, but I have no idea what it is in terms of A and B. So now I got to figure this out. Well, try to keep it as simple as possible. Let's draw a little triangle here, and let's draw a triangle here. And I hope this works out. It may not be exactly drawn to scale, but the basic idea is the same. In this triangle right here, you will notice something. I hope that the distance from there to there is A, right? That's what basically the x-coordinate is, and the distance from here to here is B. The distance, the coordinate is negative B, but the distance is B. And because this is 90 degrees right here, I've got a triangle that basically, I hope, mimics this one right here. Because this one is a 90 degrees, and if this angle in here, let's say, was theta, this angle is 90 minus theta. 90 minus theta from here to there. And therefore this angle is theta. And this angle is 90 minus theta. So those are pretty much identical triangles. So I hope I have convinced you of that. So because they're identical triangles, the distances must be the same. This must be B, and this must be A. So the coordinates would be BA. And there you go. So that's, I hope, a simple way of explaining it. Now we come to the final part of the question, which is, what do I have to do to get BA to go back to its original position? And I hope that's not going to be too difficult to understand or convince you of. You've got to reflect it sort of, let's see, in that line. So we want BA to go to AB. And what is that line? That line is y equals x. So that's it. The number 16, the answer is D. Let n be a positive multiple of 5. One red ball and n green balls are arranged in a line in random order. Let p at n be the probability that at least 3/5 of the green balls are on the same side of the red ball. Observe that p at 5 is 1 and p at n approaches 4/5 as n grows large. What is the sum of the digits of the least value of n such that p at n is less than 321/400? Well, I'm going to explain this question a little bit. First of all, they've given us some boundaries that p at n is obviously can be as big as 1, but it's got to be greater than 4/5. Okay, perhaps that will help us out. I want to explain it with a little bit of an example. Let's just say n is equal to 20. So we've got our number line, and we've got 0 to 20, and we want to see when is this true, that at least 3/5 of the green balls are on the same side of the red ball. Well, for that to be true, that means that if you have any kind of a scenario where you have a red, there's only one red, right? One red ball, then the green balls have to be distributed in a way, some on that side, some on this side, ... and so on, in such a way that at least 3/5 of them are on the same side. So, in our case, n is 20, so 3/5 of 20 is what? 12. So at least 12 have to be on one side or another. So what is a scenario that would not work? 12 works, right? If 12 is on one side. 11. If you have 11 on one side and 9 on one side, that does not work, right? Because now not at least 3/5 are on one side. At least 3/5 have to be on one side. So at least 12 have to be on one side. Another scenario that doesn't work is 10. Another scenario that doesn't work is 9. But once you get to 8, it starts to work. So, well, wait, why would 8 work? Didn't you say it has to be at least 12? Yes, but if 8 is on this side, then 12 would be on that side. They're not saying it has to be on the right side or must be on the left side. They're just saying it has to be on the same side. Okay. So now, what is the probability that at least 3/5 are on the same side when n is equal to 20? Okay. Remember, n has to be an integer because n represents the number of green balls. Well, n in this case can be anything from 0 to 8 or 12 to 20. The only bad guys are these three. So the probability basically is 0 to 8 is 9 numbers, and 12 to 20 is another 9 numbers. And the total number of numbers is from 0 to 20, which is 21, right? 0 and then 1 to 20. So 18 over 21 is the probability that if n is 20, we have at least 3/5 of the green balls on the same side. So I can write that in terms of our notation that p at 20 is 18 over 21. All right, so that's just an example to illustrate how this question works. But we have to get a general formula for n, not for 20. Okay, no problem. Let's do the same kind of thing. But this time, I'm not going to assign any number value to n. We'll just do it for n. So this is n, this is 0. Here, well here if you remember I put 12, but how did I get 12? Well, by multiplying n by 3 over 5. So that's exactly what I'm going to do. 3 over 5 times n. Here I put 8, but how did I get 8? Well, it was basically n minus this answer. So it was 20 minus 12. So n minus 3 over 5n, basically. N minus 3 over 5n. And that's 2 over 5n. So that's what goes here. 2 over 5n. So the good portion of this diagram that ensures that the probability of at least 3/5 of the green balls are on the same side of the red ball is from here to here and from here to here. And then the stuff in the middle is the bad guy. This is bad. Okay, so we have to get a formula now, carefully. So our formula will be as follows. Basically, P will be this range plus this range, right? And you can either figure out P or you can figure out 1 minus P, which would be that range. In this example, 1 minus P would have been 18 over 20, 1 minus 18 over 21, which is 3 over 21, right? So we can do that as well. I think that might be a little bit easier. So let's do that. 1 minus P, well, that's just this range here, that red line. So that red line is easily calculated, 3 over 5n minus 2 over 5n. But here's the thing. We've got to subtract 1. Now you say, well, why do you have to subtract 1? Well, think about it here. 12 minus 8 is 4. But I only have 3 numbers in there because I want to see the numbers that are in that range. They're integers. And that's why I have to subtract 1. It would be 12 minus 8, which is 4, and then I got to subtract 1 more to get only the integers inside that range. So that's why we have to do that. Okay, now that is going to be the numerator of the probability. We also have to calculate the denominator. Remember, there was a numerator and then there was a denominator. The denominator is just the total number of integers from 0 to n. So that's going to be n plus 1. Just like how before when n is 20, the total number was 21. Same thing here, it's just n plus 1. So this is our probability, and in particular it's 1 minus p. Just remember that. 1 minus p. Okay, so I think we're pretty much ready to figure this out. The numerator becomes n over 5 minus 1, and the denominator is n plus 1, and we have 1 minus p. Now they want p to be, let's see here, 321 over 400, right? Okay, but we are interested in 1 minus p, so I got to reverse this a bit. First, I'll multiply by negative, so that changes the sign around, so it becomes 321 negative over 400. And then I've got to add 1 to get 1 minus p. That's going to be 1 over 321 over 400. And that basically means that we have 1 minus p is greater than, what's that, 79 over 400? Yeah, 79 over 400. Okay, let's put that over here. So 1 minus p is greater than 79 over 400. So since this is equal to 1 minus p, that's got to be greater than 79 over 100. So that's got to be greater than 79 over 400. Got to make sure I get those numbers right. So this is n over 5 minus 1 over n plus 1. All right, let's cross multiply this. 79n plus 79, and on this side we'll get 80n minus 400. So collecting like terms, we get n is greater than 479. So n is greater than 479. So the smallest value it could be is 480. And they want you to figure out that and then figure out the sum of the digits of that. Well, the sum of the digits of 480 is 4 plus 8, which is 12. So it's a very interesting question. Number 17, the answer is A. Each vertex of a cube is to be labeled with an integer from 1 to 8, with each integer being used once, in such a way that the sum of the four numbers on the vertices of a face is the same for each face. Arrangements that can be obtained from each other through rotations of a cube are considered to be the same. How many different arrangements are possible? All right, let's discuss this. I think this is one of those things that's going to be trial and error. I don't think there's any scientific way, or maybe there is. We'll see. So here's our cube, and let's just label it really quick. I'm going to call this side 1s because I have to label them from 1 to 8. But the other sides, I don't want to do trial and error. That's not going to be very time productive. So I'm just going to call them X, Y, and Z. And then the rest I think I can get by sums. But one thing is for sure, that when you have these cubes, you have A plus B plus C plus D, right? You have 8 numbers, E plus F plus G plus H. Those are 8, right? And they all are from 1 to 8. In what order, I don't know. So they're basically equal to 1 plus 2 plus 3 dot 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 all the way up until 8, right? I don't know what is 1, what is 2, but the sums are going to match up. So the sum from 1 to 8 is 56, I believe. No, 36. 36. Okay, well, this is the key here, that the sum of the four numbers on the vertices of a face is the same for each face. So if I had, let's say, A, B, C, D on one face and E, F, G, H on another face, those two have to be the same. So that basically means that A, B, C, D, A plus B plus C plus D has to equal the same as E plus F plus G plus H. So instead of that, I'll just put in A plus B plus C plus D. And here I get 2 times A plus B plus C plus D is equal to 36. So that means A plus B plus C plus D is equal to 18. So that means that the sum of the numbers on each face must be 18. And that's a very important point. So now that allows me to label these guys without introducing too many variables. So since the sum is 18, this guy will be 18 minus the other 3, these 3. So that's going to be what? 17 minus X minus Z. And in a very similar way, I can label all the other guys. This one here will be 17 minus Y minus Z, because remember the sum has to be 18. This one will be 17 minus X minus Y. And this one we got to do a little bit of math here. And when you do, you get X plus Y plus Z minus 16. So the key thing is that the four vertices of any face, those numbers have to add up to 18. Okay, so now this is when, trial and error comes in. Not necessarily trial and error, but casework, I guess, whatever you want to call it. Okay, so we have to now test these guys. But the good news is we have a few conditions. We can label X, Y, and Z to have some sort of an order. And then also note that is a very important finding, because that will allow us to conclude that since the 1 has already been gone, the lowest this can be is 2. So that means that X plus Y plus Z minus 16 has to be greater than or equal to 2. So that means that X plus Y plus Z has got to be greater than or equal to 18. All right, so let's now see what we can get for X, Y, and Z. We got to figure this out. Okay, X, Y, and Z. Well, if Z is 8 and Y is 7, X has to be 3. 8, 6, and 4. I'm just going by this and this, trying to come up with possible choices for x, y, and z. 4, 7, and 8, 5, 6, and 7, 5, 6, and 8, 3, or rather 5, 7, and 8. And I think the only other one is going to be 6, 7, and 8. Okay, now what we have to do is we have to take these combinations and see if they fit. When you put them in, if they actually make every single side have a sum of 8, if you add up the vertices. And I'm not going to go through it case by case because that's going to be painful to listen to me. But I'll just tell you, this doesn't work. This one works. This works. This one doesn't work. This one doesn't work. This one doesn't work, but this one works. So there we go. We have 1, 2, and 3. So you say, okay, I got 3. 3 ways of doing it. Is that the answer? Well, that is one of the answer choices. And what's tricky about this is that each of these gives you 2 different combinations. And that's what makes it tricky. So the 468 can be 468 for XYZ, but it can also be 864 for XYZ, but in this order, XYZ. And I have to illustrate why those are 2 different cases. The reason is because each of those will give you 2 solutions, one with XYZ and one with ZYX. And they are cyclic, so cyclic sequences are always asymmetrical. So there are going to be 2 solutions, one with XYZ and one with the ZYX for each of the combinations of XYZ. So we have 1, 2, and 3, and each of those gives 2 each. So 6 times 2 is 3 times 2 is 6. So that means the answer to number 18 is C. In rectangle ABCD, AB is equal to 6, BC is 3. Point E is between B and C, and F is between E and C, such that BE is equal to EC is equal to FC. Segments AE and AF intersect BD at P and Q respectively. The ratio of BP, PQ, and QD is written as RST, where the greatest common factor of RST is 1. What is R plus S plus T? Let's first draw a diagram as best as we can, and let's start labeling this now. So this is going to be A, B, C, and D, and then they're drawing lines that cut BC into 3 equal parts. So let's see if I can do that. 1 equal part there, 1 equal part right there, and then 1 line from B all the way to D. So let's label this now B, E, and F, and this is 1, this is 1, and this is 1. So then they tell me that this is P, this point, and that's Q, and then they are finally telling me that this is R, this is S, and this is T. And I think that's pretty much completes the labeling. And then one final thing, of course, that this whole side is 3 and this whole side is 6. All right. So this is a similar triangles question. The first one, of course, is triangle APD is similar to triangle EPB. And when you look at the ratios of the angle, the ratios of the sides, they are the same. So BP over PD is the same as BE over AD. Okay, well, let's put in what we know. BP is R, PD is S plus T, and on this side, BE is 1 and AD is 6. Or AD, sorry, is 3. Okay, so that means that this over this is 1 over 3. So if this over this is 1 over 3, then we can conclude that R over the full distance which would be from B to D, is 1 over 4, right? For example, this is 1, it's a ratio, so 1x, and this is 3x, so that whole thing is 4x. So if we were just to compare this to the whole thing, it would be 1 over 4x, and then the x's would cancel. All right, so that's the first one. The second similar triangles relationship is with triangle AQD, that being similar to triangle FQB. And therefore the ratio of the sides are equal. BQ over QD is equal to BF over AD. So BQ is R plus S over QD, which is T, and that is equal to BF, which is what? 2, and AD is 3. So again, in a very similar way, this over this is 2 over 3. So I can conclude that R plus S over the full distance, which is BD, would be 2 over 5. All right. So another thing I can conclude is that T over BD would be 3 over 5. So whichever one you feel is more helpful. I think this one is actually more helpful. Okay, now we've got something for R, we got something for T, we need something for S now. Well, S I can just get from subtraction. S is really just this minus this. So R plus S minus R, obviously. So R plus S, let's see, do we have anything for that? We do, right here. So I guess that did come in handy. That's going to be 2 over 5 BD, and then R we have here. So that's going to be 1/4 BD. So if we do this fraction, we get 3 over 20 BD, and that's S. All right, so we are pretty much almost done with the question. Our ratio, R to S to T, therefore would be, R is going to be, according to this guy here, BD times 1/4. And then S is 3 over 20 BD. And T, according to this guy, is 3 over 5 times BD. Okay, let's try to get rid of the fractions. What am I going to multiply through by 20 probably, right? So if I multiply through by 20, this becomes 5 BD, this becomes 3 BD, and this part is going to be 12 BD. Okay, the BDs all go, and all you're left with is 5, 3, and 12. So I've got to check a couple of things. The first thing is the greatest common factor of 5, 3, and 12 1? And the answer is yes. Okay, I think that's the only thing I need to check. So now I just got to add them up. R plus S plus T looks like 5 plus 3 plus 12. And that is 20. 20 is E for number 19. For some particular value of n, when a plus b plus c plus d plus 1 to the power of n is expanded and like terms are combined, the resulting expression contains exactly 1001 terms that include all 4 variables a plus b plus c plus d and d, each to a certain positive power. What is n? Well, a few things I would like to discuss. Let's say you have 2 variables and I expand them to the 5th power. Well, some of you already know how to do this in your head, binomial expansion, but I'll just write it out. A to the 5th, 5a to the 4th, b plus 10a cubed b squared plus 10a squared b third plus 5a b to the 4th plus b to the 5th, right? And, whatever. In any kind of expansion, you'll have something like that. Well, as you can see, every term is of the form a to the x, b to the y, where a and b are obviously represented everywhere, but x and y vary. X can be whatever, right? 0 to 5, y can be also 0 to 5. But one thing is for sure, that x plus y is equal to 5. And you can see that here. In any one of those terms, the exponent for a and the exponent for b, which are x and y respectively, when you add them up, they equal 5. So in a very similar way, if you look at this expression, it would be the same sort of story. That if we have a plus b plus c plus d plus 1 all to the power of n, and obviously I don't know what n is, and even if I did, I'm not going to expand it out. It'd be way too time consuming. But one thing I can conclude is that if I have some sort of a expression, each term is of this form, the exponents, whatever you want to call them, v, w, x, y, z, let's say, we know for a fact that v plus w plus x plus y plus z is going to be equal to n. All right, just like how I did over here. So no real tricks, just the basics. Okay. But in this question, you'll notice that z is equal to 1. That's a fixed value. Since we have a 1 here, that exponent z is always going to be a 1. And also, v, w, x, and y, those sometimes could be 0 for some of the terms in the expansion. So what we will do is we will modify this. Just this guy right here. Modify. And the reason we need to modify is because currently, if you look at this guy right here, since we know that v or w or x or y can be 0, if we put it in this form, then those exponents could be 0. And the question clearly says that those have to be to some positive power. So either 1, 2, right? Can't be 0. 0 is not positive. So what we can do is, instead of writing v, w, x, and y, we can just write v plus 1, b, w plus 1, and so on. X plus 1, y plus 1. And 1 to the power of z. Z is fixed as 1, so we don't need to worry about that so much. All right, so now, based on our rule, just as before, this time v plus 1 plus w plus 1 plus x plus 1 plus y plus 1 plus z is equal to n. Okay, same as before. And now that means that v plus w plus x plus y plus z, if you put the numbers on the other side, it becomes n minus 4. Okay. All right, so far so good. No tricks. Now, I'd like to explain something to help understand the conclusion. Otherwise, the conclusion of this question may not make sense. So let's just pause here. We'll come back here. We'll put a TBD here, to be continued. And once I've explained, I will come back and I'll finish the question here. But, of course, a few things need to be explained. I'm going to start off with a little bit of an example. Let's say I have a plus b plus c plus d plus e. I think d is fine. Okay. And that equals 10. And I asked you, how many different ways can we do this? Well, you can do it in your head, but there's a system. How many variables do I have? 1, 2, 3, 4. I got 4 variables. And then how many plus signs do I have? You say, well, plus signs? What do you mean? Well, here's 1, 2, and 3. I have 3 plus signs. 3 plus signs. So there's a nice formula. And some of you have heard of this, some of you haven't. It's called stars and bars. It's not extremely popular, but it's called the stars and bars theorem, and it's always good to understand it. So this question, if I asked you how many different ways are there to do this, 4 variables, 3 plus signs. So, and that equals 10. So what you do is you take that 10 and then you add to it how many plus signs you have, in this case 3, and it's a choose notation, and it would be choose the number of variables minus 1. So in this case, it would be 4 minus 1, and this is 13, choose 3, and whatever that number comes to. Let's do another one. Let's say I have A plus B plus C plus D plus E plus F is equal to, say, 23. And I said, same question. How many ways can you do this? All right. How many variables do I have? 1, 2, 3, 4, 5, 6. 6 variables. 6 variables this time. And how many plus signs? 1, 2, 3, 4, 5. 5 plus signs. And then let's use this formula. So I take this number, which in this case 23, add to it how many plus signs? 5. And then it's choose notation, and the bottom number would be the number of variables minus 1. In this case, it's 6 minus 1. So this is 28 choose 5. Oops, 28 choose 5, like that. And whatever that number is, some big long number. All right, so now let's go back to my to be continued. Makes a little bit more sense, I think, when you've explained it. So I'm asking you now, how many ways are there to do this, basically? Okay, well, same thing. How many variables do I have? 5 variables. How many plus signs do I have? 1, 2, 3, 4 plus signs. And now let's use our formula. So it's this guy, n minus 4 in this case. Add to it, what am I adding? The number of plus signs, which is 4. And it's choose notation. And on the bottom, it's the number of variables minus 1. So in this case, it would be 5 minus 1. So this becomes n choose 4. Great. And in the question, they told me that that is equal to 1001. So it all boils down to basically solving this equation now. Okay, I think I can do that. N choose 4 is equal to 1001. Okay, well, that would be n times n minus 1 times n minus 2 times n minus 3. And then the n minus 4 would cancel, but then you'd still have that 4 factorial at the bottom. And this is 1001. But instead of 1001, I want to write it in prime factorization. So I think that's 7 times 11 times 13, this 1001. Okay, so now I've got n times n minus 1 times n minus 2 times n minus 3 times is equal to 7 times 11 times 13 is equal to, what's that, 24? Okay, so I hope you can see that that's 4 consecutive numbers. So 4 consecutive numbers equal this. Well, some of these are already factored, so let's see if I can get this in 4 consecutive numbers. Well, the 11 and 13 is close to being consecutive. I need a 12 in there. I can get that 12 from there. That would give me 2. And then that 2 combined with the 7 would give me a 14. Perfect. So if you manipulate it a little bit, you can see. So that means that, let's see here, this is n minus 1, this is n minus 2, and this guy is my n minus 3. And therefore n is 14. So that is the answer to the question. Number 20, the answer is B.